بدك اشرح لك وانت بتصور؟ صور خليني احكي. Okay, here we showing the pan boxes where stressing will be handled from above the slab. As you see here, our slab thickness here we're using 24 centimeter. As you see here, this is the anchor plate, grouting vent here. This is polystyrene in this area. So this void will remain as it is in order to enable us to do stressing from this side. This is the duct, corrugated type, galvanized corrugated duct we're using here. This is the alignment. The total length here around 35 meter. We do stressing from both ends. We have live end here and live end here. Because this slab will be used as a car park, we have used the mesh from the bottom and the top. We're using mesh T12 each 300 millimeter. Okay. The spacing between anchors around 1.6 meter here. All these areas are pan boxes due to shear wall, which we have it here, in order to avoid any restraint due to stiff members like shear wall and retaining walls all around. Also in this area where we have the core, we're using also pan boxes. Here we're using a 3-strand type in this area, and as you see here we have anti-bursting reinforcement as spiral bars here we're using. Our system is a curved anchor as you see here. Can we go? We have this internal span between columns around 9.5 meters here in this area. This slab presents basement slab. So in this case, in order to avoid the restraint effect due to shrinkage and the creep and other effects, we have used pour strip along this area. We will show you the pour strip. Also we have drop panels here in this area. These columns will be continuous, these internal columns will be continuous only for one floor. This is the pour strip here. So the creep and the shrinkage, it will be consumed in this strip. So the reinforcements are overlapping only in this pour strip. As we have said before, in order to avoid any restraint due to adjacent slabs, as you see here. We're using here, as you see here, we have very stiff columns, huge columns. These columns will be continuous because we have wooden holes above. Span of these wooden holes, it will be around 22 meters. These internal columns will be eliminated at the second floor. Okay, here we have the bars 12 each 300 millimeter. The cover here we're using 25 to 30 millimeter. Okay. This is the low point which we're using here. We're using steel chairs. This profile is a parabolic profile. Okay. So any clashing in both directions are calculated, are taken into consideration. This is the pipe here. Okay. Concrete strength used here in this project is 40 megapascal. These are electrical fittings, electrical installation here. As we mentioned before, the concrete strength using here in this project is 40 megapascal. The most important thing, as you see here, concrete in dead end and live end area to be vibrated properly in order to avoid any slippage during stressing. Okay, so stressing will be handled after 2 to 3 days when concrete strength reach around 25 megapascal. We're using in this project strands diameter 12.7, so the jacking force will be around 14.7 kilonewton, calibrated to gauge and jack with pressure around 32 megapascal. Okay. As you have seen here, we want to show you the arrangement or the distribution of landed and distributed the tendons. Please show them the view from this side. See? So the most important thing in this kind of a project, the spacing between tendons to be fixed properly as per design, and the alignment to be done in a proper way in order to avoid any friction during the stressing. Even we have taken into consideration all these factors in order to avoid any stressing problem. We hope the second stage we will show you the welding holes where the span will be around 21 meter. In this case we're using post-tensioning girders in upper levels. Thank you very much.